So when people talk about inflation, usually the measure that they're looking at is the consumer price index. So this is what it looks like year over year percent change. So you can see basically since the early 80s, it's been more or less controlled in this range. You can see that back in the 70s we had pretty high inflation, came back down after that. And these gray bars are recessions. So in a normal kind of demand shock recession, you see that inflation's usually falling. We didn't have that here, so these were supply shocks going on here in the 70s. But so basically, what the consumer price index does is take a basket of goods and just track those prices over time, as opposed to the GDP deflator that we saw, which is just using what happens to be in the GDP. So this looks at this basket of goods. There's a lot of goods in here, but this gives you an idea of the categories. So housing, which is tricky to measure a price index for that. Food and beverage, transportation, other things. So it's supposed to be a pretty representative sample of consumer prices. So we're just going to look at a simple example of how this is calculated more or less. So here we have three goods that I made: pizza, nacho, wings. So that's going to be our basket of goods. 3 units, 5 units, 4 units. And so all we're going to do is just look at the prices in some base year. And so what is the cost of this basket? So this is just broken down by each good, just add them all up. So $92 to buy this basket of goods in the base year. Prices have gone up in year two, recalculate the basket, and now cost $113. And so the CPI just creates an index using the change in this value. So each year we're just going to create an index, take the cost in the current year. So in the base year it's going to be 92 over the base year of 92, so base year CPI is going to be 100. So it's just using that base year as kind of a benchmark for all the future years and all the past years if we go in a year previous to that. And then as long as there's inflation, then this number goes up. So now it's 113 over 92 times 100. So based on this measure, we have 22.8% inflation, just the change in that index number. So just keep in mind this index is not percentage, this is just a number, and then the percent change in the index is going to be your inflation rate. So if we went again to the next year, let's say this is obviously very high inflation for 1 year, but let's say we went to 125, 130, we'd have to do percent change from 122 to 125, and that would be your inflation rate using the CPI for the following year. So pretty straightforward. I'll give you a couple examples just to think about nominal versus real changes. So here we have the minimum wage in nominal terms. So you can see it's flat over here, gets increased by Congress, flat again, and so you can see in nominal terms is just the dollar value in that particular year, but then this is now adjusted for inflation. So we're using 2017 here as the base year, which is why they become equal over here. We could have recalibrated it with an earlier base year and it would just converge at that point, and then it would start diverging after that. But you can see if nominal stays the same and there's inflation, then the real value of that minimum wage is eroding, and then we get a nominal increase, which is also a real increase, and then while there's inflation, real value erodes, right? Same thing over here. Another example, so this is housing prices, and again, getting a housing price index is a little tricky to measure, but what this is showing here is that, again, in dollar terms, the value of housing is growing over time, which is not too surprising. And so if you look at it in real terms, essentially what you're saying here in this flat part is that housing is going up more or less at the same rate as everything else. So however you're measuring the inflation rate, housing is basically just keeping up with that. So in real terms it's staying the same, while in nominal terms it's rising. And then if you have a real big increase in housing prices, so here you have greater than the average inflation rate, so in real terms it's increasing along with that nominal increase. So this is just comparing our two price measures that we've seen, CPI and GDP deflator. You can see for the most part they're telling the same story, but there are different ways of calculating it. So CPI might include things that are not in GDP. Remember, GDP is not going to include anything that's imported in that number, whereas that could be included in the CPI, so that might account for some of the differences here. But over the long run, I mean, it's more or less telling the same story. You can see it's a little more volatile over here, but they're just two different ways of measuring the price index. So here's an example of how you could actually use it to calculate the value in different years. So if you Google CPI calculator, it'll do this calculation for you, but it's very simple. All I did here was just look up the actual numbers for the CPI. So let's say we had $1 million in 1950. What is that worth today? So we know we're going to have to inflate it because there's been a lot of inflation since then. So the current CPI value is about 256. And again, remember that's just based on the base year of 100, so just relative to that. And then if you look up 1950, it's about 25. So you can see it's about 10 times the amount. So $1 million in 1950, the equivalent of having about $10 million today. And if I'm going to go in the other direction, as long as there's inflation, then I'm going to have to deflate it. So that's how I know I'm going to need this smaller number on top if I want to go from a current $1 million. Okay, what's the equivalent in 1990? Well, I'm going to have to deflate it using the CPI numbers for these 2 years. So we have again 256 here, 132. So it's about half. And so you can see $1 million today, about 515,000 in 1990. And you can see because this is 132, the base year being 100, so the base year happens to be in the 1980s. There's nothing really significant about that particular number. Everything is just based off of that base year. I'll just mention quickly a couple of problems that you have with this measurement. Number one is substitution bias. So basically, if you have, say, hamburgers in the market basket and the price of burgers goes up, well, people might substitute towards something else, which is not going to get picked up in that market basket because we're fixing that market basket. So once people substitute away from things that are becoming more expensive, it's going to tend to show higher inflation than what consumers are actually experiencing. And so that has to wait until the market basket is updated. A major issue, especially if you're looking at long-term comparisons, is going to be quality changes. So if you think about the price of a car and you're comparing it to 20 years ago, 30 years ago, I mean, the quality improvements have been so large that it's very difficult to get a meaningful measure of a price change. So think about like computers as well, and they do try to make those kinds of adjustments when they do the CPI. So they might break down a computer into its components to see that, okay, it's a 20% improvement based on speed, storage, and that kind of thing, and they'll take that into account in terms of the price increases, but it's very difficult to do that. So that is another problem with the measurement, and kind of similar to that is new goods that might take a while to show up in that market basket, and first of all, we're not getting that measurement at all, and then when they finally do make it into the basket, then prices often have already come down a lot, and so the measurement is not picking that up, and so there's various issues with trying to get a proper measurement over time.